Hello students, welcome to Educate. In this video, we will discuss about the chapter Haloalkane and Haloarine. Now, what is Haloalkane and what is Haloarine? So, first of all, you will have to go on the halogen what is. What is halogens? Group 17 elements. Group 17 elements and particularly fluorine, chlorine, bromine and iodine. That is called halogens. Group 17 elements. Group 17 elements. Group 17 elements and particularly fluorine, chlorine, bromine and iodine. That is called halogens. In the group 17 elements, there is one element also, astatine. But usually fluorine, chlorine, bromine and iodine is considered as halogens. So, in case of, and then after is what is aliphatic hydrocarbon and what is aromatic hydrocarbon. Before that, let's see here how the organic compound. Firstly, divide it into two parts. One is open chain and the second one is closed chain. Open chain and second one is closed chain. I am teaching you here because in 12th board examination question will not ask from there, but if you will not have the idea of this one, then you will feel difficulty to understand about this chapter. So firstly, the organic compound is divided into two parts, that is open chain and closed chain. This open chain is of two types. One is called saturated and second one is unsaturated. And saturated means between the carbon atom, in the molecule, there will be only sigma bond between all the carbon atom. In the molecule, there will be only sigma bond between all the carbon atom. You know already there is tetravalency. Carbon has tetravalency, means the valency of carbon is 4. So one is between each carbon atom, there will be only sigma bond. Then that will be called saturated. And if there will be double bond or the triple bond, that means if in the compound there will be pi bond also, then that compound will be called unsaturated. Saturated means between all the carbon atom there will be only sigma bonding, and unsaturated means all the carbon atom will not only bonded by the sigma bond, but there will be pi bond also at somewhere. So that will be called unsaturated. And then after here, closed chain is of two types. One is called aliphatic and the second one will be called aromatic. What is aromatic compound? The compound which follows Haloalkane's rule. The compound which follows Haloalkane's rule, that means number of pi bond will be according to 2n plus 1. Number of pi bond will be according to 2n plus 1, or the number of pi electron will be according to 4n plus 2. So basically in one bond there will be 2 electrons. So that's why number of pi electrons should be there 4n plus 2. Okay, that is aliphatic and aromatic compound. Aliphatic compound that don't follows Haloalkane's rule, but the aromatic compound follows Haloalkane's rule. Other criteria is that the molecule should be planar also. So the molecule should follow Haloalkane's rule and that should be planar also. So what's here required? That's what's basic concepts you need to understand this chapter? That's I have discussed right now. And here in your book, when you will study this book for 12th board examination, usually the question will not ask from here, but in the competitive examination, that is particularly in NEET examination and in CUET examination. CUET examination probability of asking the question from this portion is more in CUET examination compared to that of NEET examination. But the importance from there for the MCQ question cannot be denied. The question has been also asked from here. Some questions when you will consider about the PCS examination, that is not of 12th board examination level, but that is of the graduate level. There are a number of examination in which there is a number in the number of examination of graduation level in which the question from this portion has been asked. Just like that, as for example, like there is chloramphenicol. What is chloramphenicol? That is a compound containing chloramphenicol is an antibiotic. Chloramphenicol is an antibiotic. Chloramphenicol is antibiotic, and here it contains chlorine. From here, chloramphenicol, you watch out the questions when you will consider about, or you may ask from your senior who is preparing or who has been prepared for the examination of PCS level. From there, in that question examination also, question has been asked about the chloramphenicol, and its relevancy for the NEET examination is high also. And CUET examination, there is high probability of asking this question. Chloramphenicol. So that contain chlorine, and what is here? It is here, it's used to reduce the fever. Okay, so used to treat the fever in typhoid. I shall not tell what is here typhoid actually here, symptoms and like that. I shall not go in so much lengthy process. Just I am telling here there will be in the intestine due to the typhoid there will be holes and causes the typhoid fever causes high fever. That means typhoid causes high fever. So chloramphenicol is used to treat the typhoid fever. That is chloramphenicol. Then after is iodine, thyroxine hormone. That is thyroxine here. Here on this one here there is thyroid gland, and in the neck region there is thyroid gland, and there be the hormone released by the thyroid gland is thyroxine, and that thyroxine hormone contain iodine. So deficiency of iodine, if there will be deficiency of iodine, so the thyroxine gland will not synthesize, and hence the person will suffer from the disease called goiter. Someone will say, well, then what is that here? So the role of thyroxine hormone is in the metabolic activity. So that will hampers the body parts also. So thyroxine contain the halogen iodine. Thyroxine contain thyroxine hormone. You may write here hormone. Thyroxine hormone contain iodine. Okay, the role of thyroxine is to in the metabolic activity, and its deficiency causes the deficiency of thyroxine that causes goiter. Okay. Now chloroquine has been asked in a number of times. That is used to treat malaria. Chloroquine is used to treat malaria. Chloroquine. Chloroquine is used to treat malaria. That was here the MCQ questions here from here. The MCQ questions asked in the various competitive examination. And here what is firstly what is haloalkanes and haloarenes. When the halogens, that is fluorine, chlorine, bromine or iodine, when the halogen replaces hydrogen of open chain hydrocarbon or the aliphatic hydrocarbon, then the compound is called haloalkane. When the halogen replaces hydrogen of open chain hydrocarbon or the aliphatic hydrocarbon, then the compound is called haloalkane. And when the halogen replaces the hydrogen of aromatic hydrocarbon, then the compound is called haloarene. So when hydrogen replaced from open chain hydrocarbon or the aliphatic hydrocarbon, then the compound will be called haloalkane, while when the halogen will replace the hydrogen of aromatic hydrocarbon, then the compound will be called haloarene. In an examination, question will not ask what is haloalkane and what is haloarene, but that's you should know what is actually here. That means about which you are studying. What is that? So you should know. But in examination, question will not ask because this information is so much common that in the examination and particularly in the competitive examination, questions don't ask. So now let's see. Proceed here. Classification. Now we will go on the topic classification of haloalkane. Classification means how much we will classify the compounds. There will be a number of compounds here and how we will classify. So let's see. First is on the basis of number of halogen atoms. So on the basis of number of halogen atoms, there will be that a compound haloalkane can be classified into monohaloalkane, dihaloalkane, trihaloalkane. Same here, monohaloarene, dihaloarene, trihaloarene. If only one halogen atom present in the compound, then that will be called monohaloalkane. If in the compound only one halogen will be present, then the compound will be called monohaloalkane. If in the compound there will be two halogen, then that will be called dihaloalkane. And if there will be three halogen present in the compound, then that will be called trihaloalkane. And if more than three halogen atom will be present in the compound, then that will be called polyhaloalkane. In the same way, if in the halogen only one halogen will be present, then that will be called monohaloarene. If in the compound, that means in the aromatic compound, if in the aromatic compound two halogen will be present, then that will be called dihaloarene. And if in the aromatic compound three halogen atom will be present, then that will be called trihaloarene. Okay. Now here compounds containing sp3-CX bond. That means the compound in which the halogen atom will be bonded to that carbon atom whose hybridization will be sp3. Okay. So firstly, how to predict the hybridization? So when you will have to consider about the hybridization, then first of all watch out that carbon atom, the carbon atom of which you will have to find out the hybridization, you will have to watch that carbon is forming how much sigma bond. How much sigma bond that carbon will form, that much hybrid orbital will require. The hybrid orbital everywhere in any compound. The use of what is the hybrid orbital? the hybrid orbital will either do sigma bond formation or will contain the lone pair of electron. And as in atomic orbital, in molecular orbital, the hybrid orbital also contain maximum 2 electron. Okay, so whenever you will have to find out what's the hybridization, so you will have to firstly consider that carbon is forming how much sigma bond. So how much sigma bond, that much hybrid orbital will require for that carbon, and how much hybrid orbital will have to form, that much atomic orbital will merge together. How much hybrid orbital will have to form, that much atomic orbital have to merge together, and of which one atomic orbital will be of S and the remaining, in case of carbon only, and the other atomic orbital will be of P. So if, as for example, here I am telling here in one example, then after we come here. So as for example, suppose there is a compound. Yeah, primary, secondary, tertiary also I shall discuss here only. Let's see about this compound. So about let's start from here. This carbon is forming 4 sigma bond, 3 with hydrogen and 1 with carbon. So hybridization of this carbon atom will be sp3. There this carbon is forming 4 sigma bond, that is 3 sigma bond with 3 hydrogen and 1 sigma bond with a carbon atom. So this carbon atom will have to form 4 hybrid orbital, and to form 4 hybrid orbital, one orbital of S and the remaining orbital of P will have to merge together. So one orbital of S and the remaining 3 orbital of P will merge together to form 4 hybrid orbital. And since in the hybridization only one orbital of S and 3 orbital of P has been participated, that's why hybridization of this carbon atom will be sp3. Now let's see about this carbon. This carbon atom here, it is forming a sigma bond with this carbon, 1 sigma bond with this carbon, and 1 sigma bond with the hydrogen. So this carbon is forming total 3 sigma bond. So that carbon is forming 3 sigma bond. So to form 3 sigma bond, this carbon will require 3 hybrid orbital, and to form 3 hybrid orbital, the 3 atomic orbital of this carbon will have to merge together, out of which, so 1 orbital of S and the remaining 2 orbital of P will merge together. So that means hybridization will be sp2. So hybridization of this carbon atom will be sp2. Now for this carbon atom here. Now why this one here? Because this carbon is the pi bond. This bonding is double bond. Whenever there is a double bond, there will be 1 sigma and 1 pi. Sigma bond forms by the head-on overlapping of the atomic orbital, about which you will study in, you have studied in 11th class. If not studied, then that's not required here. Now consider for this carbon. This carbon is forming 1 sigma bond with this carbon, 1 sigma bond with this carbon, and 1 sigma bond with hydrogen. This one is not sigma bond, this is the pi bond. So this carbon is also forming 3 sigma bond. So to form the 3 sigma bond, this carbon also need 3 hybrid orbital, and to form 3 hybrid orbital, the 3 atomic orbital of this carbon will merge together. So 3 atomic orbital, in which the one will be of S and the remaining 2 will be of p. So hybridization of this carbon atom will be sp2. Now watch out about this carbon. This carbon is forming one sigma bond with this carbon, one sigma bond with this carbon, and one sigma bond with this carbon. As well as a sigma bond has also formed between the carbon and hydrogen. That means this carbon is forming 4 sigma bond. So this carbon need 4 hybrid orbital, and to form 4 hybrid orbital, the 4 atomic orbital of this carbon will merge together, out of which one orbital will be of s and the remaining 3 will be of p. That's why the hybridization of this carbon atom will be also sp3. Now hybridization of this carbon atom will be also sp3. You know, now if Hos, so this carbon atom is also sp3, here also sp3, this one sp3, this one also sp3, this one also sp3, this one also sp3. Now let's see about this carbon. This carbon is forming one sigma bond with this carbon and one sigma bond with this carbon. The other 2 is the pi bond. So this carbon is forming only 2 sigma bond. That's why this carbon need only 2 hybrid orbital. To form the 2 hybrid orbital, the 2 atomic orbital of that carbon will participate in hybridization, out of which one will be s, so one will be p. So hybridization of this carbon will be sp, and that of here also, this carbon is forming one sigma bond with this carbon and one sigma bond with hydrogen. So here also this carbon need 2 hybrid orbital, and to form 2 hybrid orbital, the 2 atomic orbital of this carbon will participate in hybridization. So one will be s and one will be p. So hybridization of this carbon atom will be also sp. Okay, that is about the hybridization. Just think over that. Then after we discuss about primary, secondary and tertiary carbon. Now about the hybridization, I hope that's clear. Then after, let's see about the primary, secondary and tertiary carbon atom. Now about the primary, secondary and tertiary carbon atom we will discuss. The primary carbon atom is the carbon atom which will do bond formation with only one carbon, or which will not do bond formation with any carbon atom. Like in methane, in methane, carbon is not doing bond formation with any other carbon. So this one is also primary carbon. Primary carbon, or that is also called 1 degree carbon. The carbon atom which will do bond formation with only one carbon or with no carbon, that will be called primary carbon or 1-degree carbon. In the same way, the carbon atom which will do bond formation with two other carbon, that will be called secondary carbon or 2-degree carbon. In the same way, the carbon atom which will do bond formation with other 3 carbon atom, that will be called 3-degree carbon or the tertiary carbon. And in the same way, the carbon atom which will do bond formation with other 4 carbon atom, that will be called quaternary carbon atom or 4-degree carbon atom. The carbon atom which will do bond formation with other 4 carbon atom will be called quaternary carbon atom or the 4-degree carbon atom. So now let's see here. Let's see about this one. This carbon is doing bond formation with only one carbon. So that's why it is 1 degree or primary carbon. This carbon is doing bond formation with this carbon and as well as this carbon. So that's why this carbon will be called 2 degree or secondary carbon atom. This carbon here is bond formed also 2-degree carbon atom or secondary carbon atom. This carbon is bonded to this, is doing bond formation with this carbon and this carbon. Only you will have to consider that with how much carbon atom it is doing bond formation. That means this carbon atom will be directly bonded to that how much carbon atom. That will be called, that you will have to consider. So here this carbon is doing bond formation with this carbon and this carbon. That means this carbon is doing bond formation with other 3 carbon atom. So that's why it will be called 3-degree or tertiary carbon. Now this carbon also doing bond formation with 3 carbon atom, that is this one and this one. So that's why this will be also called 3-degree or tertiary carbon. Now about this carbon is doing bond formation with this carbon and this carbon. So this carbon is doing bond formation with 4 carbon atom. So that's why it will be called 4-degree or quaternary carbon atom. Now this carbon atom is also primary carbon, you know already. Here this will be secondary, primary, secondary, primary. Very easy then after secondary, primary. Very easy it is. Okay. I think here you have not felt any difficulty about how to predict the hybridization and how to predict the carbon is primary or secondary or tertiary or the quaternary. Now let's see. Compounds containing sp3CX bond. That means we will classify those compound in which the halogen will be bonded to sp3 hybridized carbon atom. One thing here also I tell you, alkyl, the difference between alkyl, vinyl, allyl, benzyl and aryl. And watch out this point too much carefully. Watch out this point carefully. Listen, alkyl, what is that? So alkane here, suppose this is a alkane and it is propane. Few students may feel difficulty in the name. So first of all, just ABCD of the organic chemistry I am writing here. If only one organic compound, one carbon atom in the organic compound, so that will be called methane. 2. the general formula of methane is, alkane. The general formula of alkane is CnH2n plus 2, where n is a whole number. If n equal to 1, that will become CH4. That will be called methane. Same, n equal to 2, so that will be C2H6, and compound will be called ethane. In the same way, when n equal to 3, so that will be C3H8. So C3H8, that will be called propane. C4H10 will be called butane. Now I have here put only the value of n 5, 6, 7, 8 like that. And till decane you have to keep in the mind. So that's I am writing. A number of students may think that what he is teaching. Because in my teaching experience I have observed few students who don't know about this. So firstly, let's see. And that's a type of students I am finding after the students of Corona. That means after the Corona, the students who have came in 11th class or 12th class, they don't know about this one. So maybe of this year also, there be few students who will not have the information about this one. That's why I am teaching this one. Okay, the students who know about this one may just proceed from that topic here, from here, and then after from where he don't know, that's a start there. So this one, then after. You will have to mug up here and no any way apart from mugging this information. So now let's see. So if in the, that is called alkane, this one is called alkane. When there will be double bond anywhere, that will be called alkene. When there will be double bond, and that will be called alkyne when there will be triple bond. That means anywhere in this one, suppose this compound here, like this compound here. So here is double bond. In this compound there is a double bond, so it will be called alkene. In the same way, there will be, might be here like this. So in the compound there is triple bond, so that will be called alkyne. That was alkane, alkene and alkyne, that is. So alkyl halide was what? Then after vinyl halide, about that we discuss here. So in alkane, suppose I have taken butane. This is a butane here. When hydrogen removed from any places, no, I am taking here, okay. When hydrogen will replace from any carbon atom like this one. So compound will be called, so this will be the structure. From here the valency will left. So it will be called alkyl group. Alkyl group. And here when halogen is bonded here, so that will be called, when halogen will attach, then the compound will be called alkyl halide. Then the compound will be called alkyl halide or haloalkane. Okay, that was when we have taken butane. Now in the same way, if we take butene, it is butene because in the compound there is a double bond. Now if hydrogen remove from this carbon or from this carbon, that means when hydrogen will remove from that carbon atom which is saturated, means when hydrogen is replacing from that carbon atom which is doing only sigma bond formation, that means hydrogen is removing from that carbon which is doing only sigma bonding, then what will happen? The structure will be like this. Valency left here, so that will be called allyl halide. Sorry, allyl group. That will be called allyl group. And when halogen will attach to this carbon atom, that means when halogen will be bonded to that carbon atom, when halogen will be bonded to that carbon atom whose hybridization is sp3, but that will be bonded to sp2 hybridized carbon atom, this one sp2 hybridized carbon atom, then the compound will be called allyl halide or allylic halide. So when halogen attach here, so then structure will be like this. Cl or Br, what halogen you want to attach. For the halogen, we simply use the symbol X. So this compound will be called allyl halide or allylic halide. When the halogen atom will replace the hydrogen of unsaturated carbon, when halogen will replace the hydrogen of sp2 hybridized carbon atom, then that will call vinyl halide or vinylic halide. So in this one case here, if halogen attach this carbon or to this carbon, that means like this. So that will be called vinyl halide or vinylic halide. Okay. In the same way, when halogen will be bonded to the benzene ring directly, about that you have studied that when the halogen is bonded to aromatic hydrocarbon, then the compound is classified as aryl halide. Here the halogen is bonded to the benzene ring directly, then that will be classified as aryl halide. So it will be called aryl halide or haloarine. But if the halogen will not directly bonded to the benzene, that means when the halogen will not do the bond formation with the carbon of benzene, here halogen is doing bond formation with the carbon of benzene, that means halogen is directly bonded to the benzene, then it is called aryl halide or haloarine. But if halogen will be not directly bonded to the benzene, then that will be called benzylic halide. Like here carbon will be there and then after any halogen will be bonded. Like this. So here halogen is bonded to this carbon atom and that carbon atom is bonded to this carbon. So it will be called benzyl halide or benzylic halide. Benzyl halide or benzylic halide. That will be called benzyl halide or benzylic halide. Okay. So keep in the mind, in aryl halide, the halogen is bonded to the carbon of benzene ring That means the halogen is directly bonded to the benzene. Then that will be called aryl halide or haloarine. In case of benzyl halide, the halogen atom will be bonded to that carbon atom which will be bonded to the benzene. So that will be called benzyl halide. In vinyl halide, the halogen atom will be bonded to sp2 hybridized carbon atom. And in allyl halide, the halogen atom will be bonded to that carbon atom whose hybridization is sp3. But that carbon will be bonded to sp2 hybridized carbon. So that will be called allyl halide or allylic halide. Okay. So here that's the main difference, most important topic here which we'll utilize here. So 1 minute, you watch out this. Watched? Now let's see classification we discuss. Now, firstly, alkyl halide. What is alkyl halide? You know that can be the alkyl halide can be further classified into. That means compound containing sp3CX bond has been classified into three portions. One is alkyl halides or haloalkanes, allylic halide or allylic halide. Okay, allylic halide or allyl halide, and third one is benzylic halides or benzyl halide. So in alkyl halide or haloarenes, let's see here. That is further classified into primary, secondary and tertiary. The primary alkyl halide will be that when the halogen atom will be bonded to 1 degree carbon atom or the primary carbon atom. So here this carbon atom is doing bond formation with only one carbon, that is the carbon of alkyl group. So it is 1 degree carbon, and that's why, or that is also primary carbon. So that's why it is primary haloalkane or primary alkyl halide. In the same way here halogen is bonded to this carbon, and this carbon is bonded with the carbon of this alkyl group and that of this alkyl group. So this carbon is bonded to two carbon atom. So it is secondary carbon, and halogen is bonded to the secondary carbon. So that's why it will be classified as secondary alkyl halide or secondary haloalkane. In the same way here, this carbon is bonded to the carbon of this alkyl group, of this alkyl group and of this alkyl group. That means this carbon is bonded with the three carbon atom. That's why this carbon is doing bond formation with three carbon atom. So this is tertiary carbon, and here the halogen is bonded to that carbon, which is here halogen is doing bond formation with 3 degree carbon atom. So that's why this one is tertiary alkyl halide or tertiary haloalkane. Now let's see about the allyl halides. Here, watch out, halogen is bonded to this carbon, and this carbon is doing bond formation with an unsaturated carbon atom, this carbon. Actually here structure is like that, here is CH2 and here is CH. So this hybridization of this carbon atom is also sp2, and that of this carbon is also sp2. So here halogen is bonded to that carbon atom whose hybridization is sp3, but that carbon is bonded to sp2 hybridized carbon atom. So that's why this compound will be called allylic halide. This carbon is allylic carbon. So this one is called allylic halide. The carbon atom which is bonded to sp2 hybridized carbon atom. The carbon atom whose hybridization is sp3, but that is doing bond formation with sp2 hybridized carbon atom. That will be called allylic carbon. Halogen is bonded to the allylic carbon. That's why halogen is bonded to allylic carbon. That's why this compound will be classified as allylic halide. Okay, that may be also primary, secondary, tertiary. You can further classify them. Now, same here. Here, halogen is bonded to this carbon atom, and this carbon, its hybridization is sp3. 1, 2, 3 here, and one hydrogen also, which has been not shown, because that's the understood that appropriate number of hydrogen atom will be there. If hydrogen not written, then appropriate number of hydrogen atom will be there. That means so that the tetravalency of carbon will maintain. So here is actually one hydrogen also. So hybridization of this carbon is sp3, and that is bonded to this sp2 hybridized carbon atom. So that's why this carbon is allylic carbon, and this compound will be called allylic halide. Now let's see about the benzylic halide. Here, the halogen is bonded to that carbon. Halogen is not directly bonded to the benzene. Benzene is carbon of benzene is this one. Halogen is not directly bonded to the benzene. It is bonded to a carbon atom which is doing bond formation with carbon of benzene. So this compound will be called benzyl halide or benzylic halide. Benzyl halide or benzylic halide, and it can be also classified into primary, secondary, tertiary. Here it's primary because this carbon atom is doing bond formation with only one carbon. Because this carbon is doing bond formation with only one carbon, that's why this carbon is primary carbon. And halogen is bonded to primary carbon. So that's why this is 1 degree benzyl halide or 1 degree halobenzene or primary benzyl halide. Now here halogen is bonded to this carbon, and this carbon is bonded to the carbon of benzene. So this carbon, so whole the compound will be called benzylic halide, and here this carbon atom is also doing bond formation with 3 other carbon. That means 1 carbon of this alkyl group, 1 carbon of this alkyl group, and 1 carbon of benzene. That means this carbon is doing bond formation with 3 carbon atom. That's why that will be 3 degree benzyl halide or 3 degree benzylic halide. Okay guys, now let's see about compounds containing sp3-CX bond. Vinylic halide here. So in vinylic halide, halogen is directly bonded to sp2 hybridized carbon atom, so it will be vinylic halide. Here also halogen is bonded to sp2 hybridized carbon atom, so it is also vinylic halide. In the same way, halogen is bonded halogen is bonded to directly benzene. Halogen is bonded to the carbon of benzene. Here halogen is bonded to the carbon of benzene, so that's why it will be aryl halide. Here also halogen is bonded to the carbon of benzene, so that's why it will be called aryl halide. Okay, so in the classification that was only here. Then after we will discuss the portions which I have discussed right now. Directly questions don't ask from there. From there directly questions don't ask, but if you will not know about those concepts, then you could not solve a number of questions which frequently asked in 12th board examination, NEET examination, the IIT main examination and CUT examination. Because these portions were just like the basic concepts. These were the basic concepts to solve the questions asked oftenly in IIT, NEET, 12th as well as CUET examination. So, but from the nomenclature, the topic nomenclature, questions frequently asked, and from about this one, these questions also, if I shall tell you the rule regulation and then mugging the rule regulation, you could not solve the questions in the examination. So I shall tell you how to write the IPAC name of the various compounds, and when you will practice a number of compounds, then you could solve the questions related to nomenclature frequently asked in IIT NEET. Here for this one, here for the NEET examination, yes, nomenclature not asked so much difficult. So IIT NEET and CUT as well as for the 12th board examination. And if you have watched the question bank, then you may consider, watch out. You have realized, you might have realized that one questions oftenly asked in IIT main examination as well as in the NEET examination are related to nomenclature. So the questions related to the nomenclature we will solve in the next class. It's all for this class. Thank you, Team Education.